Thank you so much, and wonderful to be with you. What I want to do in the next 20 minutes is to give you a scientific update on the challenges we're facing over the next decade and decades to come in terms of a transformation towards a safe operating space, and not only within safety, but also allowing prosperity and equity for humanity on Earth. And the place to start is, not surprisingly, in Glasgow, where humanity joined Glasgow in November last year on a pathway to disaster. We have overwhelming scientific evidence that we are on a path that would take us to a 2.7 degrees Celsius global mean temperature rise by the end of this century, in only less than 80 years' time. This is a place we haven't been in for the past 4 to 5 million years. It is a disaster point. We left Glasgow on a pathway to danger, meaning that if all countries would implement the pledges, the nationally determined contribution updates, the methane pledges, the deforestation pledges, the net zero pathways that were put on the table in Glasgow, the best estimates is that we could hold the 2 degrees Celsius line. So we went in disaster, we leave potentially in danger. But the latest science, which you see to the left on this graph, is actually showing that there's so much at stake. Unpublished research now in review shows that already at 1.5 degrees Celsius, we have moderate risks of crossing tipping points that would push the Earth system irreversibly away from livable conditions for humanity. And that already at between 1.5 and 2 degrees Celsius, we actually have high risks of destabilizing big global commons such as the Arctic ice shelf, the Greenland ice sheet, the Amazon rainforest, and I'll come back to these. So the more the science advances, the higher is the risk at very early stages of global environmental change to trigger irreversible changes, which is a very strong scientific support for the need of a planetary boundary framework. Already in 2009, the planetary boundary science suggested that something like 1.3, 1.4 degrees Celsius is the climate planetary boundary. Beyond that, we take rising risks. There is scientific uncertainty, but the risks are high. So essentially, we're still following a trajectory towards high risk, and science is advancing and showing more and more that lower temperatures is the only safe future we have. And the implications are already today proving that we're in the middle of a global climate crisis. For the first time last year, we had rain falling at the highest peak of Greenland. We have mass loss on all glaciers in the world. And just look at the spike on Iceland, one of the hotspot regions on planet Earth, because we have an amplification of global warming, which means that Iceland, Greenland, northern Canada is warming twice as fast as the planet on average. We have a situation where now the IPCC shows clearly not only that the severity of extreme events are increasing, but even the frequency. We get more heat waves, more extreme rainfall, more extreme droughts, more forest fires, and they are more severe, and they're attributed to human-caused global warming. And remember, this is happening already at 1.2 degrees Celsius of global warming, which is the warmest temperature since we left the last ice age, but it's still quite far away from 1.5 and 2 degrees. And the emissions continue rising. The 2021 data shows that we have not bent the global curve of emissions yet, and the journey we have to follow is a tremendous exponential journey to net zero within one generation. Why? Because the IPCC shows clearly, this is the graph from the latest assessment, that to be able to have a landing possibility at 1.5 degrees Celsius, we only have something like 400 billion tons of carbon dioxide remaining in the global carbon budget to have a 67% chance of a soft landing at 1.5 degrees Celsius, which is again a manageable threshold, but already causing major impacts. But why do we get 400 gigatons of remaining carbon budget? Well, and this is the focus of my talk here, it's not enough to only phase out fossil fuels. No, you see, the only reason the climate models gives us still some degrees of freedom to land safely at net zero by 2050 is that it assumes a transition of land use in agriculture from being the single largest emitter, shown here in dark brown, the wedge you see to the left here, to transition into becoming the world's largest net sink of carbon dioxide, shown in orange, an agricultural sustainability revolution. But even more importantly, it assumes that nature will continue to be our best friend. In green, absorbing roughly 25% of carbon dioxide in terrestrial intact ecosystems on land, and another 25%, even more than 25% actually, in the ocean. So overall, the only chance we have of, one, landing softly at 1.5 within the climate planetary boundary, and two, to be able to still allow ourselves, let's say, an orderly phase out of fossil fuels to have 400 gigatons of carbon dioxide remaining, is that we stay within planetary boundaries. We have to return really fast so that we can keep the carbon sinks in nature intact. That's the only chance we have to be able to deliver. That is why the planetary boundary framework has become, largely a guide to be able to navigate the transformations required in the Anthropocene. We have 9 planetary boundaries that science now shows clearly are the system that regulates the state and stability of the Earth system. Climate is just one of the 9, but not surprisingly, land, freshwater, biodiversity, and 2 big cycles of nutrients, nitrogen and phosphorus, are also planetary boundaries. And these are the biosphere boundaries that regulates the ability of the Earth system to be able to sequester carbon, cycle elements, and cycle energy and water, and keep air clean. 4 of the 9 boundaries in 2015 were assessed to be transgressed beyond the safe operating space: climate, biodiversity, land use, and biogeochemical flows, meaning overuse of nitrogen and phosphorus. Just 2 weeks ago, a new paper was released showing that we also transgressed a 5th boundary, namely what we call novel entities, which is chemical pollutants and the accumulation of human-created chemical elements in the Earth system. So we are truly in a danger zone and need to move fast very rapidly, and the only chance of even landing climate is actually to take care of nature in a responsible way. Now, the journey to a safe landing on the climate part, to stay within the 400 billion tons of carbon dioxide, is dramatic. Just look here at what net zero pledges means for the big economies in the world. China is just increasing its emissions, the world's largest emitter today. Look at that landing zone, which, even if it's too late, net zero by 2060, is a dramatic exponential journey of more than 10% reductions per year of emissions. Look at the United States, the European Union. Here we're talking of massive transitions towards a net zero future, and at the same time transitioning to sustainable management of the entire biosphere. So therefore, dear friends, is why science is forced to look at this little beautiful Earthrise from the Christmas Eve Apollo 8 picture from 1968, and today scientifically have to ask the question, are we at risk of destabilizing the whole system? And what will it take to return back to a safe space? And here is the latest data on this. Here is the classic map that came out 1 year before the first planetary boundary science was published on the tipping element systems that we have scientific evidence regulates the climate system. This has been updated, and just 1 year, 2 years ago now, we mapped all these tipping element systems and could show the scientific evidence of the 9 of the known 15 systems that are starting to show signs of instability. And these 9 are shown in this map. The planetary boundary framework is quantifying safe boundaries to avoid that these are pushed across tipping points. And you see here, you're very close to home with the Arctic sea ice, the Greenland ice sheet, being essentially a ground zero, not only because they are approaching risks of tipping point, but also because they're connected with many of the other tipping elements. These connections we call cascades, and in the 10 new insights in climate science, published just before Glasgow, handed over to Patricia Spinoza at the UNFCCC, shows that the latest science is something that we really need to take on board, namely the interactions, cascade, domino effects we risk if we push some of these tipping elements too far. So just to give you one example shown here, the Greenland ice sheet is melting fast, and it's releasing cold fresh water into the North Atlantic. This slows down the Atlantic overturning of heat, the Gulf Stream. This slowdown impacts the position of the tropical monsoon systems over both West Africa and South America. This can explain the higher frequency of droughts and forest fires over the Amazon rainforest, which in turn leads to a pulse of carbon into the atmosphere, an amplifier of warming. But not only that, the slowdown of the overturning of heat locks in more warm surface water in the Southern Ocean, which in turn leads to a feedback of accelerated melting of the West Antarctic ice shelf. So you have a situation where the amplified warming on Iceland and on Greenland in the Arctic is connected all the way down to the functioning of another tipping element, the Amazon rainforest, and the stability of the Antarctic ice shelf. This is what we need to learn. Here you have an unpublished map where we are doing an update right as we speak of the 15 to 20 big tipping point systems that we need to keep stable to have the chance of a thriving, equitable future for humanity on Earth. You can just see from this map that it's not only the big ice sheets, it's not only the heat in the ocean, it's also the big natural ecosystems on land. It's the temperate forest, the boreal forest, the wetlands, the peatlands, the permafrost, the Amazon and the Congolese and Indonesian rainforests. So here we have a situation where we have to take an integrated approach where all the planetary boundaries matter. Our latest assessment of why I, in the first slide, could say that already 1.5 degrees Celsius is a risk point for us comes from our latest assessment of the temperature thresholds of these tipping elements. And here you have the graph, also unpublished data. Look at the 5 systems to the furthest left here, that these red embers columns here is the uncertainty range in science. The average point of risk for crossing tipping points is shown in the dotted line. And look at the Greenland ice sheet. We today have uncertainty range between 1 and 3 degrees Celsius, but an average point which is actually even below 1.5 in terms of risk of crossing an irreversible point of no return. So it's really so much at stake at this point of a necessity of a turnaround. And just to take one step back, to give you the perspective of the Earth system, what you see here is the first time a climate model has been able to reproduce the state of the climate on planet Earth over the past 3 million years. The entire quaternary. This is what you see on the x-axis. On the y-axis you have global mean temperature. The 0 point is the pre-industrial average temperature on Earth, 14 degrees Celsius. And the green line shows the reproduction with only physical and mathematical equations of the Earth's dancing in ice ages, interglacials, ice ages, interglacials, the last 3 million years. The only thing I want you to kind of take in here is, if you look at this graph, not at one point have we passed 2 degrees. The Earth system has had as its warmest point below 2 degrees, warm interglacials, and deep ice age is roughly -4 degrees. That's the corridor of life. -4 deep ice age, under 2 the warmest point. And now we are rushing to a point that would take us to 2.7 degrees Celsius. In my mind, do we need more than this graph as a justification for rapid action? I would say no. But it's even more dramatic than that. We have more and more scientific evidence why the planet has been able to stay within this narrow corridor, and it is thanks to the resilience in the Earth system. It's the ability of the ocean and land to absorb and dampen the stresses and forcing caused by, before we started burning fossil fuels, solar radiative variations, and now caused by us. The IPCC 6 assessment actually concludes that 56% of our burning of fossil fuels and land use change, the carbon dioxide emitted by us, has been absorbed by terrestrial ecosystems and the ocean. So over half of our debt is subsidized by planet Earth. Unfortunately, we have more and more science like this showing that capacity on land, at least, is showing cracks. The Brazilian part of the Amazon rainforest has already tipped over the last 10 years from a carbon sink to now being a carbon source. This is what makes science really nervous. And the IPCC confirms this important understanding of the longer time scale. The last 100,000 years we've actually never passed 1 degree Celsius warming, and the IPCC concludes the need to recognize the incredible pace of change and how dependent we are on the stability and resilience of nature to buffer and absorb the changes. Back to Iceland and other coastal countries and human settlements in the world, the sea level rise is continuing at a 3.4 millimeters per year, 3 centimeters per decade. This is a linear trend. We are facing something like 60 to 100 centimeters this century. But remember, we're just at the very early stage of a long-term unstoppable trend. This is IPCC data. Even if we're able to land at 1.5, this is the box you see to the furthest left, the long-term commitment on sea level rise, even if the short-term commitment, we're talking 50 to 90 centimeters by this end of this century, the long-term commitment is 2 to 3 meters over a 2,000-year period. If we not able to hold the 1.5 line, but end at 2 degrees Celsius, we would have more than 6 meters of long-term commitment. This is because of the inertia and the unstoppable, irreversible changes that would be triggered, particularly from the West Antarctic ice shelf, Antarctica, thermal expansion of the ocean, and on Greenland. So however we twist and turn this, there's so much at stake. There's science showing that at 1.5 degrees Celsius, we would push coral reef systems across tipping points. We have so much evidence that the West Antarctic ice shelf is more sensitive than we've previously thought, and that the climate planetary boundary is confirmed around 1.5. We also have data, as you know, in the Arctic that things are changing faster than we had anticipated. So again, the Arctic region and Antarctica is giving us so much evidence in support of planetary boundaries. But this is not enough. And what really concerns me is that we don't understand that the reason why things are, despite the fact that things are changing fast now, they're changing much more slower than they otherwise would have done, which is thanks to the ocean. The ocean is absorbing 95% of the heat caused by our fossil fuel burning and 25% of the carbon dioxide. This is extraordinary, and we depend on it, but it's also causing impacts on the ocean biology. Now, we have recently shown that the ocean stability in the future will probably be the decisive factor, and science is quite uncertain of the future here. But when we look on land, on the other hand, we start seeing that the ability of the land system to continue absorbing 25% of our greenhouse gas emission debt is starting to be reducing gradually. And in a paper that we published recently in the Proceedings of the National Academy of Sciences, we show that if it hadn't been for the ability of the nature planetary boundaries to stay healthy, we would already today have had 0.4 degrees Celsius warmer temperature than we see at 1.2 today. In short, if we hadn't had nature, we would already have crashed through 1.5. Unfortunately, when you look into the future, it's uncertain whether this capacity of buffering will continue because of forest fires, disease patterns, droughts, and human expansion of agriculture and infrastructure into natural habitats. So to close, I really want to strongly argue that science shows so clearly that we have to redefine sustainable development in the Anthropocene. Now we're talking about human well-being and equity within planetary boundaries. We have to have, at any scale, if we are in Iceland, a company, a financial institution, or a community, we now need to connect to the entire planet. Economically, this is now starting to really be understood. The Sarpatha Dasgupta Commission, which was published last year by the UK government, really showed a new direction for economics. The economics within planetary boundaries, something that Kate Raworth will be talking about following my talk here. And I'm really excited about this growing understanding that we need to have an economy that develops within a safe operating space of a stable and resilient Earth system, and that this is strong sustainability. It translates to regulatory means, to economic policies that forces societies and economies to stay within the boundaries of a stable Earth system. So I would put, in my handover to Kate, of course, humanity, equity, prosperity, justice, right within that safe operating space, and that is the let's say, the guiding mindset that we need to have a chance in this quite turbulent but also very important transition phase for humanity on Earth. Is there then something positive around the corner? Well, I would say yes. I mean, I haven't talked anything about that. I could spend an equal or even much longer time to add up all the positive trends of the fact that we're starting to see an ability to tip over also on a social tipping point towards accelerated journey towards a safe landing. So the risks are high, time is running out, but we're also seeing progress and movement and technologies and scalability. There's no longer utopia to reach a safe operating space. It's about pace and scale. With that, I hand back the word to you. Thank you very much.